Let's take a look at these geometric series. These are infinite, and we know that the sum of an infinite geometric series is S equals A over 1 minus R, where A is the first term in the series and R is the common ratio. Let's rewrite these a little bit so it's easier to determine A and R. So this series starts at 0. I'm going to rewrite this summand as 3 to the negative 2 to the k, which can then be rewritten as 1/9 to the k. So now we're in the standard form for an infinite geometric series, and we can identify A and we can identify R. So A is the first term of the series, which is going to be 1. We plug in 0 for k to get A. The common ratio, when we have an exponent of k, is going to be whatever is in the parentheses down here. So that common ratio is 1/9. This then tells us that the sum of this series is A, which is 1, divided by 1 minus the common ratio, which is 1/9. So this will be 1 divided by 9/9 minus 1/9 is 8/9. And our sum will be 9 divided by 8. Let's take a look at the second one here. So again, let's rewrite this in a way that is going to make it easier for us to figure out what both A and R are. So that negative 2, we can apply that to the 1/4, so that's going to flip the fraction, make it 4 to the 2, which is 16. So we have 16 to the k. Once again, A is going to be 1, because the first value of the index is 0, 16 to the 0 is 1, common ratio is 16. Now here we have to be a little cautious. We can only apply this formula up here if we have a convergent geometric series. So if you plug in the A and the R, you will get a value, but that is not going to be the sum of the series because this series diverges. This R is greater than 1, which tells us that the series diverges. All right, let's take a look at the third one. This one we have a little bit more fiddling to do. First off, notice that that minus sign is not in parentheses, so that minus sign is acting like a -1 multiplied by the 2 to the k minus 3. So I will factor that minus to the outside. And then in the numerator, I'm going to treat this as 2 to the k times 2 to the negative 3. In the denominator, I'll treat that as 3 to the k multiplied by 3 using laws of exponents. Those constants can come out to the front. So we have a negative, and then in the numerator, that will be 1/8, which will push that 8 into the denominator. So we will end up with 1 over 8 times 3. Series goes from 0 to infinity of 2/3 to the k. Okay, so now we can simplify this to -1/24 out in front, multiplied by this simplified series, k 0 to infinity, of 2/3 to the k. And we can identify A and R very easily now. So A will once again be 1, and keep in mind that we're looking at the series piece of this expression. In the end, we will in fact have to multiply by -1/24 to get our total sum. But we're going to treat these as two separate factors. So the series factor will have A equals 1. When we plug in this initial index, k equals 0, 2/3 to the 0 is 1. And then the common ratio is going to be 2/3. This tells us that the sum of the series is going to be A divided by 1 minus R. So that is going to be 1 divided by 1/3, which is 3. So now our total sum is going to be -1/24 multiplied by 3 which will be negative 1/8.